Okay, so we've got this rod AB suspended from like a ceiling, I suppose, with two strings. So tension in two strings, T1 here, T2. Tensions are not going to be the same, all right? Especially because here we've got this weight suspended here, 10G at this point C, if you read the question, which is 0.3 meters from A. Of course, the rod itself is uniform, so the weight here is focused at the center. Okay, 6 kilograms the mass of the rod, so 6G the weight there. And we're asked to work out the tensions in both strings. Okay, now we'd expect the tension in this string to be greater because you've got the weight you've got this extra weight added on here, so there's going to be more stress on that string there. So what I do, right, because it's in equilibrium, again, we say, look, forces up equals forces down. Okay, so the forces up in this case, well, T1, T2, the strings, and that would equal to then the weight of the rod plus then this mass causes this weight here of 10G. So you get T1 plus T2 equals to 16G. Okay, and you know, we could work that out. Okay, T1 plus T2, 16G, well, 16 times 9.8 will be 156.8 newtons, right? So that's my equation 1. To get equation 2, then, second equation, because I've got an equation here with two unknowns, haven't I? Two unknowns. I could take moments then, maybe take moments about a point where one of the tensions goes through. So I could take moments about A, or I could take moments about B, all right? So if I take moments about A, okay, of course, the T1 has no effect through A in terms of the moments. The clockwise moments, well, if you think about it, if my center here, these would be going clockwise, wouldn't they? The 10G and the 6G. So I'll have 10G times the distance there, which is 0.3, plus then the 6G times the perpendicular distance, which is 0.7 when you combine them. And that will equal then the moments anti-clockwise, okay, which will be the T2, isn't it? If you think about it, it's taking the anti-clockwise, T2 times then the whole distance to A, which is 1.4. Okay, so a bit of calculator work here. Okay, we've got 10G, of course. Well, that would be 10 times 9.8 times 0.3 plus then the 6 times 9.8 times 0.7 equals T2 times 1.4. So I can work all that out. We get there 70.56, which equals to T2 times 1.4. So then to get T2, I'll do 70.56 divided by 1.4. So T2 will equal 50.4. Okay, so if T2 equals 50.4, I can then work out what my T1 is by subbing it in to 1. Okay, so if I call this 2, I can say, look, sub 2 into 1. So I'll have T1 plus 50.4 equals 156.8. So I can get my T1 then, which is 156.8. Take away the 50.4. So I can get my T1 out. What have we got? 156.8. Take away 50.4, and I get out 106.4 newtons. And as we described, there'd be more tension in that string here. Okay, so we're done.